YouTube. I'm APC, and today I'm making the GameMaker tutorial. In today's GameMaker tutorial, we're going to be covering particles. This tutorial was suggested by Nimmler725 several months ago. I haven't covered it because I didn't know how to do it. But a few weeks ago I learned how to do it, and I used it in my game to practice, and now I feel like I have a pretty good understanding of it, and I'll teach you. I learned it by watching a few tutorials, but the most helpful thing when it comes to learning particles is to know that all the information nice thing about particles is they make your game seem significantly more professional without that much more work. So for this tutorial, no sprites are required, so we're just going to create an object. Call it obj particles. Okay. In the creation event, we're going to pretty much do all the code for our particles. We're going to set all the settings. So first off, we need to create a system. First name, I'm going to call my SYS, short for system. I said equal to part system create, and just like that. So now you have a system. The system, you can perform global commands on all your particles. So now the system's created. Let's create a particle using the system. So we're going to name our particle part, and we're going to set equal to part type. Particles can be found under help. Content, GameMaker language, unique settings for the particles, and how you want them to be. There's like about 20 of them actually. So, but today I'm going to go over like the big 5. So first, we're going to talk about the shape of the particle, and that is part type shape. That's the function, and in all of these settings functions, the first argument is the part you're dealing with, particle you're dealing with. In this case, we need a particle part, so that's what we're going to name it, and then the shape. There are 14 built-in shapes for particles, and each of those shapes are simply 64 by 64 sprites, and they're designed in a way with specific transparency and that kind of thing to look perfect for particles. So they all are called PT shape, and then I can go through the whole list right here. But the one we're going to use today is my favorite one, which is pixel, which is just a basic dot. So now you got shape taken care of. Let's talk about the size of the shape. So type part type size, and I got first thing I got to do is say which particle is part of. Next argument is you can look at all the arguments done here, by the way. And that's what I'm reading from right now. The size is multiplied by the current size. So if I type down 1, it'll be the same size as it is in the actual sprite. So we're going to say it's going to be, and the maximum size is 2. So it'll be between the normal size and double its normal size. For size increase, let's add just a little increase, 0.1. And then for size wiggle, which is basically random change in the size, we'll say 0.02. Alright, so that's 2 down, 3 to go. Next one we'll go over is direction. Next one we'll go over is color. Very important. So part type color. There's like 6 dealing with color, but for now, know that there's 1, 2, and 3. 1, you only have 1 color and it stays that color. 2, it starts at 1 color, and then you say which color you want to change to. And 3, starts at 1 color, go to the second color, and then the third color. But today we're just going to do color 2. So first, which one you're dealing with, part. And then I want mine changed from red to orange. So we'll say C red, and then we'll say C orange. Okay, that's all it's supposed to. Now 2 more to go. Next one we're dealing with part type direction. Which direction do we want our particle to move in? So part, name of the particle, the minimum direction, so we'll just say 0, and maximum is 360. So direction is completely random, and then just work just like size. Do we want direction to increase? No. Do we want direction to change randomly at all? Sure, why not? I'll say 5. One thing about direction increase, if you give a direction increase, make it to say, let's say make it 10. This will make it particles end up looking like they're forming a circle, turning counterclockwise. To make it -10, they'll be turning a circle clockwise. So if you don't want them to form a circular pattern, don't do any increase at all. So for the last one, we'll talk about the speed, because you're not going to notice direction if there's no speed. So part is the one we're working with. The minimum speed we want to be anywhere between 5 and maximum like 10. The speed increase is less noticeable than the direction increase or the size increase, but we'll just give a number for that good. 1 is fine. And speed wiggle, randomizing between speeds. Randomization in the speed, we'll just make that 1.5 or so. Now one thing I want you to notice here is that speed, direction, and size are set up in pretty much exactly the same way. Many of them are set up in this way, so if you understand one of them, you understand all of them basically. So these are all our settings for our particle. So now next thing we're covering is within particle systems. There's a lot of these things, objects that control the particles. An example that would be particle destroyers, which every time the particle comes within this destroyed region, they'll just be destroyed. This may be something you want to do when it collides with solid or something like that. You can also use a deflector, so it'll like bounce off solids. But the one we're going to talk about today is emitter, so which initially creates the particle, which is something you obviously can't live without. So we're going to call our emitter emit, set it equal to part emitter create, and this requires one argument, which system is the emitter part of it. We'll just call it SYS because that's the name of our system. Next thing that's important about the emitters is what region will the emitter have, around what region will the particle be created. So the way you do that is say part emitter region, and first what system is this part emitter region part of? SYS. What emitter are we talking about? Emit. And then we go over the emitter region. Now I want it to be emitted at a specific dot. So we want our x-min, minimum x and maximum x to be the same thing. So say x and x. And then min y and max y, same thing. They need to be both the same. And now the shape. Now let's say that these min x, max x, min y, max x, if they formed a rectangle and we chose for shape make a rectangle, then it'll just be simple as that. But there's a coordinate. So look at that. Find this long rectangle. So you those buildings and like that. Since we're only making one specific point, these will all have the same vector. We're just going to do rectangle, which is one you're usually going to be using. Distribution. There are 3 different distribution types, and they're all constant. I'm going to go through all of them since only 3 of them. Linear, it will evenly be distributed throughout the whole region where they're being emitted. Gaussian is they're going to be more focused along the center of the region being emitted. Inverse Gaussian is the opposite, they'll be focused more along the outside. So we're just going to do linear. Again, it doesn't. These 2 things don't matter if you just go to the specific point. So now let's create the particles. So the way you do that, there's 2 ways of creating the particles. You can either do it with a burst or a stream. But today we're just going to do burst because they're a little easy to understand. So it's going to be part emitter burst. What system? SYS. What emitter? Emit. And what particle? Part. And we're going to create 100 of them. One thing to note about that number is that you'd be surprised how many particles your computer can handle in one room at the same time, like count 2,000 or something like that, if under some circumstances. It's pretty crazy. But also, you got to be careful not to go too crazy with particles, because if you do have too many, then it'll really slow down your computer. So now we want, so this will create 100 particles within our region, and and then the particles will start acting from there as we create the settings. I want this to happen every second, so I'm going to create an alarm. I'm going to set alarm 0 equal 30. So under alarm 0, we're going to put that burst code again. So put down part emitter burst. What system? SYS. What emitter emit. What particle part, and 100 of them.
Wait.
And then we'll reset the alarm. Okay, so now let's create a room. I'm going to make the background white so that we can see the colors better. And we're going to add the object smack in the middle of the room. Alright, let's test it out. So there it is. Works pretty well. The one thing you don't notice here is it's supposed to change from red to orange. The reason why you don't notice that is because the default life is 100 steps. We'll be learning about how to change that in our next tutorial. But the point is that by the time I start changing colors, it's already outside the room, so we don't notice it. But other than that, it's working perfectly. So, and you got like a pretty basic explosion here without too much work. So that's all for this part of the tutorials. I'm going to be making 2 more of these, and I'm going to be covering some more advanced stuff in later tutorials. So that's all for today. And if you have any suggestions for tutorials that you might want, please suggest them. And that's about it. See you guys next time.